A parallel beam of light from a laser with a wavelength of 632.8. That's, by the way, the red laser that I use in class. The helium neon laser, that's the wavelength, right? Falls on two very narrow slits, 0.032 millimeters apart. The fringes are 6.7 centimeters apart on the screen, some distance away. What is the distance to the screen? Okay, so you can use this, right? Let's use this, and then we can use the actual angles and inverse tangent and stuff like that. And you can see, if you really want to, you can see that they give you the same answer. Okay, but let's just go ahead and do this, right? So this is the distance on the screen. On the screen. This is to the screen. That's the wavelength of light. So in this case, we'll use that, right? Okay, and then this is the separation, which will be this, okay? So let's just go ahead and find the D doing that, right? So the bright fringes are 6.7 centimeters apart on the screen, some distance away. So we're going to go S is lambda D over D, right? So that means that's 0.067 centimeters. That's our distance apart on the screen, right? Is 632.8 times 10 to the minus ninth times the distance to the screen that we don't know, divided by the distance separating the slits, which is 0.0320. Notice that that's millimeters, so that's times 10 to the minus third, okay? Which is what I tend to do with millimeters, because I'm really not very good at the whole moving the decimal point type of thing. Okay, so D is going to be this times this divided by that. So 0.067 times 0.032 times 10 to the minus third divided by 632.8 times 10 to the minus ninth. And I get 3.388. So big D, the distance to the screen, is 3.388 meters, or about 3.39 meters. Now, I know that you're looking at that and going, I don't know about that approximate formula there, right? Because this thing tells you the actual angle to it. So let's do that. Okay, let's figure that out, right? So we'll just make this 1, right? Let's figure out what the angle is, right? Okay, so we're still doing A here. So we'll go 1 times 632.8 times 10 to the minus ninth, right? That equals 0.032 times 10 to the minus third. That's our little d, times the sine of that angle, right? Because I know you don't believe that the sine of the angle actually equals the angle at small angles, but it kind of really does. Okay, so if I want to find that angle, I'm going to go second sine, okay, of 632.8 times 10 to the minus ninth, divided by 0.032 times 10 to the minus third. And then also divided by 1, by the way, because we're just, the 1 there means that we're going from one bright spot to the next. We're not skipping any, right? Okay, so that angle is 1.133 degrees, because I happen to still be in degrees. We could do this with radians, and it might be a bit easier, right? Okay, so now we know that that's the angle, right? So we've got and we've got like this, right? Okay, so now I'm going to use inverse tangent, right, to figure out what this side is. Here's the, this is the adjacent side. Here's the opposite side, right? Okay, and so if I go this way, let's see. So tan theta is opposite over adjacent, right? Okay. So we're trying to find the adjacent side. So the adjacent side is the opposite side divided by the tangent of that angle, okay? So let's do that. The opposite side is 0.067 meters. Let's divide by the tangent of this angle. Okay, I've got it now. 0.067 divided by the tangent of the number I just got. And I get a slightly different number. I get tan of, that's 1.133, right? When I do that, I get, what do I get? I get 0.3, oh, sorry, 3.387. So it's still 3.39. Okay, but these digits here get a little bit shaky, right? So really this is a little bit more precise, but you know, with 3 sig figs, it didn't make a difference. Okay, we can use our high-powered trigonometry, right? We can use the approximate formula, okay? And just encourage you to do that. The IB test is a timed test, okay? All right, so what angle separates the central fringe and the third order fringe? What distance is this on the screen? Let's do that. Okay, for the angle, I encourage you to use this guy here. Okay, now 20.1, do you suppose that's just 3 of those? Let's just try that. 6.7 times 3. Hey, look at that. Okay, so the 20.1 centimeters, since we're going from the central fringe to the third order fringe, that's just 3 of these gaps, right? Okay, so 20.1 at some level is just 3 times the spacing of those things. So 3 times 6.7. Okay, that works, right? But let's be good citizens here and not forget that they did teach us trigonometry. Okay, so we're going to use this guy here, right? Okay, so we're going to go the central bright fringe and the third order fringe. So we're going to go 3 times, because this is from 0 to 3, right? Okay. So the third order fringe, the 0th order, by the way, is in the center at an angle of 0 degrees, right? Okay, so we're going to go, what is the angle of the third order fringe? So that's, this n is now 3. Okay, so 3 times 632.8 times 10 to the minus 9th is equal to d, which is 0.0320 times 10 to the minus 3rd, because it's millimeters, right? Sine of theta. So let's find theta, right? Theta is going to be second sine, so the inverse sine of this times this divided by this. I can do this. All right, 3 times 632.8 times 10 to the minus 9th divided by 0.032 times 10 to the minus 3rd. And did I do that right? I hope I did. Ooh, wow, okay. So theta is 3.40 degrees. Yay. All right. And then, by the way, if you wanted to figure out what distance that was on the screen, let's do that, okay? The screen is 3.39 meters away, and we know this angle is 3.4 degrees, right? So this is our opposite side. Here's our adjacent side. And so this distance here, this opposite side, is going to be 3.39 times the tangent of 3.4. Okay, so I'm going to go take my distance to the screen, the 3.387 or whatever it is, right? Times tangent of the number I just got. And righteously, I could figure out that this distance is 0.201 meters. The next digit's a 3, by the way. Okay. So either way, you can just say, look, if it's the third order fringe, it's going to be 3 of the separations, and it's 20.1. Or you can use your trigonometry. Okay, it's just sort of basic maths.